After defining the geometric model for a steel building, one of the most important aspects, with regard to this type of structure, is the management of connections. To manage the connections, we access the Steel Connections view, and from here we can work to define the connections between the elements. First of all, it will be necessary to insert a crossing for those columns that are continuous. For example, we select these two elements and insert a crossing to tell the program that there is continuity in this point. We can select this crossing and copy it to the other nodes. But the steel columns have predefined dimensions, so at some point will also be necessary to insert an interruption. To do this, there is the break command, so let's apply this function on this column. Also define a precise dimension inserting the numerical value. Then, with the copy function, let's break all the other columns of this model. After a column has been split, it is necessary to restore the structural continuity of the column. Therefore, let's insert, between these two pieces, a connection. And here the software will show all the solutions compatible from the archive. For example, we want to carry out a connection with joint cover. In this case, we are entering the editing of the connection. Therefore, in the connection properties we need to define all the relevant parameters. For example, the diameter of the bolts. We can choose the number of rows of bolts to be inserted, if we want them at the core and at the wings. While we edit the properties, we see that the object is dynamically updated. With the detailed visualization, we can also have a preview of what will be the final drawing, the constructive detail of this link. Once the choices have been made, we can then end the process. Again, we can copy and paste this connection for all those columns that had been interrupted with the break function. Let's now see how to manage a beam column connection. For example, in this case, we select this beam and this column and imagine that we want to insert a flange connection. Again, let's get right into the connection editing environment. Here we choose the diameter of the bolts. From here we define the size of the plate. We can also decide to add shelves and also apply a rib to the beam. As we already did before, we customize the number of bolts. We can insert a bolt in the center of the beam and provide additional bolts in these other positions. As soon as we have correctly defined the properties of the object, we can end the process. Through the copy function, it is possible to duplicate this connection in all the nodes in which the program can make that type of connection. Now let's insert the link between the beams and the core of the column. We then insert a connection of the flange type. Let's define the dimensions of the bolts. If necessary, add a further bolting to the center of the beam and terminate the connection. This connection must be extended also to the opposite side. Therefore, it is sufficient to select the two beams and the software proposes the flange extension, so that with an additional plate completes the connection first inserted. With the copy function, we can extend that type of connection to all other nodes. The function of being able to display the not connected nodes is particularly useful. Through this command, the software indicates all those nodes in which the connection has not yet been inserted. We then proceed to insert the plates in the foundation. From the Connection Properties panel, let's change the length of the anchor bolts. We can also change the type of anchor, for example, simple anchor bolts, rosette bolts, or with hook. With each of our changes, the software dynamically modifies what will be the final blueprint. Let's finish copying it to all the other nodes. Once the insertion of the connections is completed, we are ready to proceed with the calculation of our model. In the calculation preferences, we choose the type of seismic analysis, while in the standard data, we quantify the seismic input. So we give all the necessary parameters to be able to define the spectra. And once we have defined the elastic spectra for the various boundary states, we can perform the calculation. From the calculation menu, it is then possible to carry out the full calculation or by step. At the end of the processing, we obviously have the diagnostics. Diagnostics in this case highlight problems of displacement excessive to the damage limit state. It is quite justifiable since in our model we have not inserted vertical braces, and also problems are reported with regard to the connections in the foundation, therefore checks not met for the foundation plate. By double-clicking on the error message indicated by the diagnostics, we are immediately returned to the steel connections view and we can start checking the numbers. In particular, for example, we are going to check the anchor bolt and we find problems with regard to the traction check of the anchor bolts, with a safety coefficient less than 1. At this point, without cancelling the calculation, we edit the connection and make changes. We increase the diameter of the anchor bolts. We are also going to add more anchor bolts both in one direction and in the other. We increase the size of the weld beads. At this point, when we finish the connection, the software dynamically performs the same connection check. So if we go to the results, to check the anchor bolt checks, we notice how those error messages on the traction check have disappeared. When we decide that this connection is adequate, because it satisfies all the checks, we can think of copy it to all the other nodes. Therefore, we are asked to replace the previously inserted connection. And at this point, the software dynamically proceeds to review all the nodes based on the new dimensions and new characteristics assigned to the links. We go back to diagnostics and note that all the problems concerning the plates in the foundation have actually been solved. At this point, we cancel the calculation to discover other features of the software. In steel structures, it is often necessary to insert trusses. There is a default object in the menus that is precisely the truss. In the properties of the object, it is possible to choose first of all what the truss model is, being able to count on a fairly widespread archive. For example, choosing this type. Then the truss must be characterized from a geometric point of view. To do this, simply select the object and here on the right go to define the section and the material. At this point, the insertion of the truss is immediate, always snapping to a node of the magnetic grid. Proceeding from node to node, we insert our objects. But, until now, the truss object is just a drawing. In the structural model there is no trace of this object. Therefore, we select the elements and on the right in the properties, we proceeded to generate the structure of the truss in such a way that it is also physically present in the finite element model. If we have to insert purlins, we should insert steel beams. Let's immediately define a more suitable section. For example, we will choose the omega, and in this case we also have a function of recognition of these beams or purlins directly from the truss object. In fact, by activating this flag, with a simple selection rectangle, we can insert the rods directly on the trusses. Let's now see how to manage the nodes of the truss steel connections. First of all, we can observe that these links, although we have added new auctions, have not been eliminated. Therefore, we can also proceed to select these beams, to move them by about 10 centimeters, then in the properties of the objects under the item functionality we then proceed to lower these beams by 10 centimeters. Returning to the view of the steel connections, we notice how, even in this further modification, it does not delete the inserted connection. We then proceed to insert the connections in the nodes of the truss rods. First, we can select the top current rods and tell the program that in this node in fact the top current is a continuous rod, while the other beams are connected to the higher beam through one of these solutions that the software offers, then either with bolted connections or with welded connections. For example, in this case, we have chosen a bolted connection. As usual, in the properties of the objects, it will then be necessary to characterize the connection by defining all the geometric properties. As usual, the software already prepares the construction documents and therefore, once we have made our choices we can terminate. Surely a particular node is this. Here we must define a connection between the first upright and the lower beam of the truss and then complete this node by also inserting the support plate on the column. Another particular node is this, in which there is clearly no continuity between the rods and therefore, we would immediately insert, for example, a connection of this type here. Clearly, we will then proceed to complete the insertion of the links in all the other nodes of the truss, for example, using the copy function seen previously. But the diagnostics also reported another problem, that of excessive displacements, and another object that you can insert into the program is the vertical bracing. In this case, just click on a first column, a second click on the other column, and here the object is inserted. In the properties of this element it is necessary to clearly characterize first of all the sections of the individual rods, the type of material and so on. Once again this object is just a drawing, it is not present in the structural view, it will be when we are going to generate the structure of the bracing directly from the properties of the object through this generate structure function. In this way, the bracing rod will be physically present in the model. And let's see how to change the view of the connections due to the presence of braces. In this case, we don't have to insert a new connection, but we just have to complete the already existing one. By selecting the beam rod and the bracing rod we have the possibility of extending the flange first inserted, so this flange would be completed through the insertion of a new plate through which we connect the bracing rod to the structure. The same applies to the foundation. We are simply asked to extend the foundation link first inserted. We can proceed with a welded extension or with an extension in which the bracing rod, always bolted, is connected to the plate. Now, all these connections that we have inserted, if we perform the calculation of the structural model we obtain a construction document with all the construction details. By performing the first step of the calculation, the structural model and carpentry one, we can consult the view of the steel frames. Here we already find the design of the trusses with the detail of all the connections inserted, the same thing if we go to consult the frames. We therefore have the representation of the frame as well as the details of all the connections inserted. If we select a connection and check it, we also see that the location is indicated. And this is clearly for all the links that have been entered.